Assalamu alaikum. In this video, we'll learn about the random variables. There are many ways that we can define a random variable. Two most important things that we must note here is that firstly, it's a variable, so it can have different values. And secondly, it's random, which means that the value of it is determined by random phenomena. We can define it as a variable whose value is unknown and depends upon some random events, or a variable whose possible values are numerical outcomes of a random phenomenon, such as a random experiment, or a rule or a real valued function that assigns a numerical value to each outcome in a sample space. A variable whose possible values are numerical outcomes or of a random phenomena, which we have seen already. Random variables takes on different values determined by chance. So there is the notion of probability associated with each value that random variable can take on. It provides a means to map the outcomes of a random processes to numerical values. For example, if we record the gender of the next 3 people entering a shopping mall, the sample space would be all females, FFF, first 2 females, then male, FFM, FMF, MFF, and so on. The size of the sample space is 8. We get 8 different combinations. If we observe 4 people, the possibilities will become 2 raised to power 4. For 5, it is going to be 32, 2 raised to power 5, and so on. Each of these outcomes are equally likely. Instead of doing it this way, if we start recording the number of females in these people observed, the outcomes become strictly numeric, and they're reduced to only 0, 1, 2, 3, or 4, depending upon how many people you're observing. So for 4%, it is going to be 0, 1, 2, 3, or 4. This is a random variable mapping the outcome of the above experiment to numerical values. So you can go back and see that when we were describing this experiment as the way we had been doing it earlier, the sample space consisted of these outcomes. And now, when we have transformed this into a random variable, we have fewer options for the values of the random variable, and also all of those values are now numeric. Random variables quantify the outcomes of a random experiment. Each value of the random variable has an associated probability. The values of random variables are numerical representations of the outcomes or the simple events of random experiment. Each value has an associated probability, just like the case of simple events, and the probability values range from 0 to 1. The sum of all probability values for the different values this random variable can take on must be 1. Random variables are represented by capital letters, such as this example X, the number of red cars in parking lot of the university. This can be a random variable, or the girls to boys ratio in a family. This can be a random variable. Random variables can either be discrete or continuous. For discrete random variables, they can only assume a countable number of different values. And those real values can be those can be real values or integers, but the possible options that are available for a discrete random variable are countable, or you can enumerate those values. Examples are number of errors in a software program, number of students passing this course, how many students walk 10 miles per day regularly, or the number of girls in an average Pakistani household. So you can see that most of the times it is related to some counts or numbers. For the continuous random variable, it can assume infinite values of the sample space. For example, the maximum weight in kilograms a girl students of BSc can lift, the time taken by a student to complete a programming task, the distance from home to work for employees of an organization, or girls to boys ratio in a family. Now you can see this, that with continuous random variables, you cannot possibly enumerate all the values that it can take on. Let's do this little exercise and find out whether each of these random variables mentioned here, whether they represent a discrete valued random variable or the continuous valued random variable. The first one is the age of a girl student at the time of admission to BSSC program. This is a continuous random variable because we cannot possibly list all of the ages. Practically speaking, this might be uh, quite counterintuitive, but actually this numerical value can have many different possibilities because the ages can be represented as um, uh, if it is in years, then we can take it as something discrete, but generally the ages can be on the continuous scale. The number of lipsticks owned by a 2 years old Pakistani girls, this is countable, so this is a discrete random variable. The probation of it, the proportion of a day's time the teenager is spending on the social media. Again, this is a continuous variable because the length of time that we compute um, can have can be on a wider range on the number line, and we cannot possibly list all the possible values it can take on. The average calorie intake of a 19-year-old girl residing in Rawalpindi, this again is continuous, and the percentage of female victims of cyber crimes among the crimes reported during a given month. This again is a context variable because we cannot possibly list all the values that this variable can take. The number of boys residing in Gulbar Green Residencia who help their moms with the household chores, this is a discrete random variable. Now, the guidelines for the probability distributions of RV, we will be using random variables as the basis for the probability distributions, which are an essential part of the inferential statistics that we will be covering in the coming weeks. So how we can create the probability distributions for the random variables, the steps are given here. We list all the possible values of RV. We find the frequency of each value, make a frequency distribution table for the possible outcomes, find the sum of the frequencies, and then we find the probabilities of each possible outcome by dividing its frequency by the sum of frequencies, which this is equivalent to taking the relative frequencies. And finally, check that each probability is between 0 and 1 and that the sum is 1. Here we can carry this process out with the help of an example, and this will make us understand the process better. This is an experiment which constitutes on spinning this given spinner 2 times, and the sum is recorded. The probability of landing on 1 is 0.25, and the probability of landing on 2 is 0.75. Now, since x, the random variable that we're considering, is the sum of the 2 spins, we first need to list all the possible values that x can take on. So it could be that in both of the spins, we get a 1. So the sum is going to be 2. It can happen that the first spin gets a 1 and the second one gets a 2, in which case the sum would be 3. Or the first spinner gets a 2 and the second one gets a 1. Again, the sum is going to be 3. Or the case when both of the spins, they show a 4. A 2. So in that case, we're going to get the sum as 4. Here we create the probability distribution table or the frequency distribution table for the values of the random variable. From spin 1, if we have 1, 1, we have the value of x2, 1, 2, 3, 3, and 4. 3 here is listed 2 times, but actually when you would be writing the sample space for the random variable or any sample space for that matter, you list the values only once. The outcomes of the spins are independent. So the probability every time is the same. For 1, it remains same. For 2, it remains same. So P of 1 in any spin is 0.25 and P of 2 in any spin is 0.75. Law of simple multiplication of probabilities apply here because the event of getting a certain probabilities, they are independent of each other. So we can, in order to find out the joint probability, we can simply multiply the respective values. So here we compute the probabilities of this event. So for the first case, when we get a 2, the actual events which happen are that we get a 1 in the first spin and 1 in the second spin. So the probability of this is computed by multiplying the probability of these respective events. In order to, the probability of getting a 1 in the first spin is 0.25. The probability of getting a 1 in the second spin is 0.25. So we multiply these to get 0.0625 as the probability of this event that we got 1 on each of the spins, and the sum in this case is 2. For the next value where we get a 1 on the first spin and second on this 2 on the second spin, the probability of 1 on the first spin is 0.25, but the probability of 2 on the second spin is 0.75. The multiplication of these two values gives us 0.1875 as the probability for observing a sum 3. Remember that 3 can occur in two ways. Either it is 1 on the first spin and 2 on the second spin, or 1 on the second spin and 2 on the first spin. In both cases, we have the same probability, which is 0.1875. So it is listed here twice. The fourth case is when we have 2 on both of the spins. And since the probability of getting a 2 on each spin is 0.75, the probability of getting 2 on both of the spins is 0.75 into 0.75, which is 0.5625. And when we sum these, we get 1. And now frequency distribution table, since we cannot have the same value listed twice, we add up the probabilities and list this value for RV, which is 3, because 3 could be achieved in two ways, as we've discussed. So we add those probabilities up and list 3 only once in this table. And again, when we add these probabilities, we get the sum as equal to 1. And we can also draw a histogram representing this frequency distribution table. Here you can see that the probability of 4 is highest, and the probability of getting a 2 is lowest.